Hey guys, it's me, Mr. Farrader. Let's talk a little bit in this particular set of notes about the movement of water. Now, I'm pretty sure that you guys at this point, after all the years that you spent in school, are pretty comfortable with the notion that the water cycle is a pretty important part of how water moves around the surface of the earth. So you don't need me to do a ton of review with you. But I do want you to take a quick look at this slide, and especially want you to look at this very first bullet. The sun is actually really important as a driver of the water cycle, and that's because it leads to two of the most important parts of the water cycle: condensation and evaporation. You know, evaporation is when the sun heats up a water source and water vapor evaporates, turns from a liquid into a gas and enters the atmosphere. And then condensation is when that same water vapor cools down and falls back to the surface of the earth in the form of liquid water. So what's kind of interesting to me is that the sun is the driver of both of those things. And whether or not you understand the water cycle, I wonder if you had that in your memory from your previous science classes. So the major focus of 8th grade science when it comes to the water cycle is what happens to the water after it falls back to Earth. Where do we find it on the surface of the Earth, and how does it work while it's here? And I really like this graphic because it kind of shows you all of the different places where you're likely to find liquid water on Earth. Obviously, we all know that streams and lakes are places where water is stored. But did you also know that water was stored underneath the ground? And not only is it stored underneath the ground, but it's stored in several different areas under the ground. It's stored in something called the saturated zone, which is part of the soil that is saturated with groundwater. And then it's stored in these things that are called aquifers. And those are things we're going to pay attention to during the course of this unit. That might be a new word for you. So one of the biggest words in this particular unit of study, or in this particular section of notes, is runoff. Runoff means the precipitation that falls to the earth. And it courses over the surface of the earth. You can kind of see that word in bullet number 1, which I thought was really cool. When it courses over the surface of the earth, it's going to end up in streams and in rivers and in lakes. That's probably not a surprise to you. But those aren't the only places that runoff can accumulate. Sometimes it's going to freeze onto our glaciers or into our polar ice caps. And then other times it's going to infiltrate the ground. Do you see that word? It's down here. It's going to infiltrate the ground, which means seep into. And it's going to accumulate in those places. And we call that groundwater. Now, if water is going to infiltrate the ground, then we need to talk about, well, how porous is the ground? And another science word for porous is permeability. Permeability is the ability of a rock or sediment to allow water to transmit through it. Some rocks, some sediments are very permeable, meaning water runs right through it without any trouble at all. Other rocks, other sediments are not very permeable, which means that water won't pass through it. Instead, it will build up on top of it. Does that make sense to you? In fact, you can see here that if water is impermeable, or I should say it differently, if sediments or rocks are impermeable, then water will not pass through it. That's an important word. Either way, that idea of permeability allows water to seep into our ground and then get stored there. Isn't that wild? Like, oftentimes when I think about water on the surface of the earth, I'm thinking about lakes, rivers, streams, creeks, water that I can see with my eyes. Even glaciers and pools pop to my mind when I'm thinking about water on the surface of the earth. But what's particularly interesting and important in this particular part of our unit is that there's a substantial amount of water that's actually stored underground. And we call those deposits of groundwater, we call them aquifers. Okay, so that's a funny name for a place underground where lots of groundwater is stored. Now, Why should we care about aquifers? Well, the answer is really easy. That's water that we can extract and then use for other purposes, whether it's farming or whether it's drinking. And I think we'd all agree that having access to water that's drinkable is probably not a bad thing in today's day and age, right? Now, when we're talking about runoff, or that precipitation that falls to earth and then is carried away, another thing that we need to talk about is the term river basins. Now, when I first started teaching 8th grade science, I was like, oh, I know what a river basin is. That's the area where a river just flows across the surface of the earth. Like maybe a river basin is the width of the river plus a little bit of the land on the sides. That's actually an incorrect assumption. I was wrong when I started to teach 8th grade science. Maybe you could call the width of the river and the land on either sides, you might be able to call that a river valley, but that's not what a river basin is. See, here's what a river basin is. Every drop of water that falls onto the surface of the earth is either going to end up in groundwater, in those aquifers we just talked about, or it's going to drain off into a river and then be carried out to the ocean. Listen to that again. Every single drop of water that falls on the earth is either going to end up in groundwater or be carried into creeks, streams, rivers, and eventually out to the ocean. Well, all of the land that is drained into one particular river, or all of the land where the water that lands there is carried into one particular river, is what we call a river basin. And literally every single part of the Earth's surface sits inside of a river basin, even if there's not a river that's nearby you. You know, I think about Carrion Apex, where I live, and I can't think of a river that's all that close by. If I wanted to drive to a river, I guess I'd have to go to Falls River, right? In Carrion Apex, we're not surrounded by tons of rivers. However, I can 100% take you to the creeks that are closest to my house. See, and those creeks are a part of a river basin system. When rain falls in my backyard, it's going to drain eventually either into groundwater and be trapped there, or it's going to end up in one of the creeks that's close by my house. And guess where those creeks connect to? Right, they end up in larger streams, which end up connecting to rivers, which end up eventually emptying into either an estuary or an ocean. And remember, we talked about those in the last sequence of our unit. Okay, so I want you to understand that every piece of land on Earth is actually a part of a river basin. So wherever rain falls on the Earth, if it's not getting trapped as groundwater or frozen as a glacier, it's definitely going to start running into creeks and streams, which will eventually connect to a river, which will eventually connect to an estuary or an ocean. And guys, here's why that's so important. That means all of our actions, every choice that we make, no matter where we live, has an impact on water quality in the regions that are downstream from us. Let me give you an example. I have my yard fertilized by a fertilizer company. Well, when rain lands in my yard, that fertilizer gets picked up by the runoff. And some of it is going to be carried into creeks and streams that are nearby here. And then guess where those creeks and streams flow? Right? Into a river. And guess where that river flows? Well, downstream into the ocean. That means all of our individual choices, no matter who you are or where you live, have an impact on the quality and health of the water, of the runoff that ends up in our rivers and our streams, and eventually in our oceans and in our estuaries. So we have to be really careful and deliberate about what we're doing simply so that we don't pollute our water systems. Here in North Carolina, there are 17 different river basins. So there are 17 areas of land that drain into different rivers and river systems. And depending on our topography, which means the elevation of our land, some of those rivers drain into the Gulf of Mexico and other of those rivers drain into the Atlantic Ocean. It's kind of neat, right? To think about the fact that depending on where you live, the water that lands near you is either going to end up in the Atlantic or the Gulf of Mexico. Okay, last slide for this particular section of notes. Take a look at this map of North Carolina. It's showing you all of our different river basins. And so what that means is each of those particular areas of land drain. The water that lands there, if it's not trapped as groundwater, will eventually drain into a particular river and then be carried off to sea somewhere else. What's important for you to do is figure out, well, which river system or river basin do you live in? Because it's your obligation to do your very best part to help keep that river basin and the waters that drain through your river basin clean and healthy for other people to drink when it runs downstream.